Hello everyone, welcome to the video explanation for Brian Passwater's topic 3-9 notes example 2. Now before we actually get to the example, I want to real quick talk about inverse trig functions. Remember that when we look at the sine function, the cosine function, or the tangent function, and we want to talk about having an inverse of that function, we cannot do that. An inverse does not exist unless a function passes the horizontal line test, unless there is only one input for each output. So when we look at these sine, cosine, and tangent graphs, what we are doing is we are restricting the domain so that we only have a piece of the function that does represent every possible output for that function, but it also passes that horizontal line test and only has one input for each output so that we can have an inverse function. So we're restricting those domains. Now the reason that we're restricting sine to negative pi over 2 to pi over 2 is, again, that represents every possible output of sine, and it keeps our values as close to the y-axis as possible. Same thing with cosine. We go from 0 to pi because, again, that represents every possible output of cosine, and it keeps our x values as close to the y-axis as small as possible. Same with tangent. We go from negative pi over 2 to pi over 2 because that is one full tangent wave from the vertical asymptote to vertical asymptote. And that piece of the graph passes that horizontal line test, so that would allow us to have an inverse function. So example 2 says, evaluate the following expressions, and it says the inverse cosine or arc cosine of negative root 2 over 2. Well, that means we're looking for the value in that 0 to pi range that has a cosine value of negative root 2 over 2. Well, the x-coordinate where it has that negative root 2 over 2 is our pi over 4 angle in the third quadrant. That is 3 pi over 4 radians. So you're basically being asked what angle has a cosine of negative root 2 over 2 in that range of 0 to pi radians. The answer to that is the angle 3 pi over 4 radians. For part B, we're asked to find the arc cosine of negative root 3 over 2. So again, there we are looking for the point that has a y-coordinate of negative root 3 over 2 in our restricted range of negative pi over 2 to pi over 2, which is our restricted range for sine. Now, that value would be the pi over 3 angle in quadrant 4. Okay, and that is, that's the point with the coordinates of 1/2 negative root 3 over 2. Well, that is an angle of negative pi over 3, okay, which, remember, that is coterminal with that 7 or 6 pi, 5 pi over 3 angle. Okay, so when we say, well, what is the inverse sine of negative root 3 over 2? In the restricted range of negative pi over 2 to pi over 2, that is negative pi over 3, which in reality is equivalent to a 5 pi over 3 angle. Finally, for the inverse tangent of root 3, we are looking for the value that has a sine of root 3 over 2 and a cosine of 1/2. It has to be in quadrant 1 or quadrant 4. That is, again, our sine has to be root 3 over 2, and our cosine has to be 1/2, so that when we divide our sine by our cosine, we get root 3. That is your pi over 3 angle in quadrant 1. So again, when we say what angle has a tangent of the square root of 3 in that restricted range of negative pi over 2 to pi over 2, that is the angle pi over 3. So that would be our output there. Okay, our output would be 3 pi over 4 for part A, negative pi over 3 for part B, and pi over 3 for part C. And remember that that has to do with the restricted domains of your cosine, which is from 0 to pi, for sine, you're going from negative pi over 2 to pi over 2. And for tangent, you're going from negative pi over 2 to pi over 2. You're not including those pi over 2 values because they are vertical asymptotes. So again, your answer to any of these questions should match those restricted domains.